Hi guys, how's it going? Okay, so here we go. This will probably be a pretty long one because this is a pretty hefty study guide. Anyhow, what is the sum of the degrees of the interior angles of a 23-agon? So we're going to use the formula n minus 2 times 180. And where the n is, we're going to plug in 23 minus 2 times 180. So that will be 21 times 180. And you will get 3,780. Okay, so now if the sum of interior angles of a polygon is 2,160, how many sides does it have? So we're going to do n minus 2 times 180 and set it equal to the total measure of angles. First things first, we divide by 180, divide by 180, and we end up with n minus 2 equals 12. To get n by itself, we will add 2 and add 2, and we will end up with n equals 14. All right, what is the measure of one interior angle of a regular heptagon? Well, that's 7 sides. So we are going to do 7 minus 2 times 180. But because we're looking for one interior angle, we're going to divide it by the number of sides. Okay, so 7 minus 2 times 180 is 900. Divide that by 7, and you get 128.57. A decimal is okay if it's an angle measure, but it's not okay if it's the actual amount of angles. So 128.57 is okay because that's an angle measure, right? But if we're counting the number of angles, like in this triangle, it would be 3. That needs to be a whole number, right? Because you can't have a partial angle. Angle measure, meaning what's inside the angle, that's okay. All right, what is the sum of exterior angles of an 11-agon? Sum of exterior angles, no matter how many sides it has, is 360. All right, what is the value of one exterior angle of a regular pentagon? So regular meaning all sides and angles are congruent, pentagon meaning 5. And since it's an exterior, we're going to do 360 divided by 5, and we will get 72 degrees. Okay, so for question number 6, find the value of x. So what I'm going to do first is I'm going to find the total measure of angles by counting the sides. 1, 2, 3, 4, 5. So I'm going to do 5 minus 2 times 180, and I'll get 540. So now I'm going to add up all of these sides and set it equal to 540. Well, on my own, before I made the video, I went ahead and added these up. I got 419, all of these angles, plus x. So then I'm going to subtract 419 from both sides. And I'll get x equals 121. All right, same thing here. I'm going to count my sides. 1, 2, 3, 4, 5, 6, 7, 8. All right, it's an octagon. 8 minus 2 times 180 will give me 1080. So now I'm going to add up all of these angles. And I'm doing that just to save time on the length of this video. I did that before. So I added all of my x's, and I got 43x, plus I added all of my constants, and I got 392. That equals 1080. So now I subtract 392 from both sides, and I'm left with 43x equals 688. I'll divide by 43 and divide by 43 and get x equals 16. All right, that is page 1. Let's make our way to page 2. Okay, so this is a regular, let me just scooch this up a bit. Regular pentagon, meaning it has 5 sides. All right, that means that each of these angles, because it's a regular pentagon, are going to be the same measure. So what I'm going to do is I'm going to use the formula for finding each angle of a regular polygon. So the number of sides minus 2 times 180 divided by the number of sides. 5 minus 2 times 180 all over 5. Well, that's going to equal 540 divided by 5, which will give me 108. So that means each of these angles are 108 degrees. I'm going to take 7x plus 31 and set it equal to 108. All right, I'll subtract 31 and subtract 31 and get 7x equals 77. Then I'll divide by 7 and divide by 7 and get x equals 11. Okay, now this one. All right, these are all exterior angles. And what do exterior angles add to? 360. So what I'm going to do is I'm going to add all my x's right here, right here, right here, and right here. And I'll add them together and get 30x. I'll add all my constants. -5, positive 29, 61, positive 13, and so on. And I get 150. So now I subtract 150, and I end up with 30x equals 210. Divide by 30, divide by 30, x equals 7. Okay. Find the area of the parallelogram shown below. So remember, the area for a parallelogram is just base times height. What I need to make sure to put in here is a right angle so you know that they're perpendicular. Well, if that's 19, then this is 19. Opposite sides of a parallelogram are equal. And my height would be 13. Remember, we don't use the slant. We use the one that's perpendicular. So I'm going to do 19 times 13, and I'll get 247 units squared. Okay, find the area of the parallelogram below. Show your answer as a simplified radical. Please make sure you're reading stuff like that on your test. You will lose points if you don't write it as a simplified radical. Okay, so I know that my area is equal to base times height. I know my base is equal to 24. I need to figure out what my height is. What I see right here, hopefully you guys see too, is a right triangle. So I'm going to draw that over here, this right triangle. And this is 16, this is 45, this is 45, and obviously this is 90. And we're back to 45, 45, 90s. And hopefully you remember the sides, n, and rad 2. Okay, so we're going to solve for n. 16 equals n rad 2. We'll divide by rad 2 and divide by rad 2 and get n equals 16 over rad 2. Can't have a radical on the bottom, so I multiply the top and the bottom by rad 2. And I end up with 16 rad 2 over 2, which simplifies down to 8 rad 2, because 16 divided by 2 is 8. So now I know that this side right here is 8 rad 2, and this side right here is 8 rad 2. I now know my height, which is 8 rad 2. and I'm going to multiply my base, 24, times my height, 8 rad 2. And remember, just multiply those numbers, 24 times 8. You'll get 192, and then tack on the radical at the end. I'm writing units squared. I might forget some. Don't worry, I'm not going to dock you points if you don't write them. Okay, so next one. This is a composite figure, right? A few figures shown together. And the way that my brain sees it might be different than the way that yours sees it. I'm marking this triangle up here. And then right here, I'm marking this larger quadrilateral and then this smaller quadrilateral. So I'm going to find the area of my first triangle. So maybe I'll do that over here. First, I know the area is equal to base times height divided by 2 because it's a triangle. So to find the base, I'm going to do 34, the length of this whole segment, and I'm going to subtract 16 because then it would give me this distance. So 34 minus 16 is going to be equal to 18. So I know my base is equal to 18. And my height, well, I know that the whole thing is 29. All right. I need to take away this piece, which is 8, and that piece to get this remaining. So I'm going to do 29 minus 8 minus 11, and I will get 10. Okay, so I know my height is 18 and my base is 10. My base is 18 and my height is 10. Now I can find my area. 18 times 10 divided by 2. 180 divided by 2 will give me 90. So my area for this figure is 90. Now let's figure out figure number 2. Okay, well, to find my base, again, I'm going to do 34 minus the 16. So base is going to be 34 minus 16. And again, still 18. And then for my height, we're just simply going to add, because I just want this distance right here. I'm going to add the 8 and the 11 and get 19. So it's a quadrilateral. The formula is simply base times height. So 18 times 19, and I will get 342. So 342 for this figure. And now my last little quadrilateral, which has your height and your base given to you. So 16 times 11 is equal to 176. And what I do now is I simply just add my areas together. Oh, whoops, I don't know why I highlighted 10. I meant to highlight 90, not the 10. Not the 10. Okay, so total area. 90 plus 342 plus 176, and I get 608 units squared. Not too bad, huh? Once you just break it down, like any math problem, right? Okay, solve for the area of the triangle. Well, this one's not too bad. We have our base and we have our height. So area equals base times height divided by 2. Well, my base is 22 times my height, 13 divided by 2. I will get 286 divided by 2, which is 143 units squared. Okay, Solve for the area of the triangle. Answer should be a simplified radical. Ooh, and look, we've got a 60 and we've got a 90, which means this is 30. So what I'm going to do is I'm going to redraw this triangle right here. Okay, and I know that this side is 2n, right, across from 90. This side is n rad 3, and this side is n. So first things first, I'm going to solve for n. 2n equals 20. Divide by 2, divide by 2, n equals 10. Because n equals 10, I'm going to plug this 10 right here where n is. So 10 rad 3. Okay, well, now I know that my height of this triangle is 10 rad 3, and my base is equal to 32. So I'm simply going to do 10 rad 3 times 32, all of that divided by 2. Right, that would, I'm running out of room. 320 rad 3 divided by 2 would simplify down to 160 rad 3 units squared. Okay, we're making decent progress. Next up here is find the area of the trapezoid below. So remember, the area of a trapezoid is B1 plus B2 times your height divided by 2. So base 1 and base 2 is going to be 10 plus 14. And we're going to multiply it by our height, which is 6. And I don't know why I wrote H. It's 6. And that's going to be 10 plus 4 is 24 times 6 is 144 divided by 2. And your area would be 72 units squared. All right, number 16, tricky problem alert. The area of the trapezoid, is 540 centimeters squared. The perimeter, meaning the distance all the way around, so if we were to go all the way around this trapezoid, is 71 centimeters. If one leg is 17, so this leg is 17, and the other is 18, find the height of the trapezoid. Okay, so that seems really tricky, but it's not too bad, because what we're going to do is we're going to think of area equals base 1 plus base 2 times your height divided by 2. Well, we don't actually need to know base 1 and base 2. We just need to know what they add to. So if we take the perimeter and we subtract the two legs, we actually have the sum of the two bases. So I'm going to go ahead and take 71 minus 17 minus 18. I'm going to get 36. Okay, so now I'm going to plug what I know into the equation. So I know that my two bases added together are 36 times my height, which I don't know. It is divided by 2. And then I know that the area is equal to 540. So I'm going to get rid of this 2. It's saying divided by, so I'm going to do the opposite and multiply. And I will have 36H equals 1080. I'll divide by 36 and divide by 36, and I will get my height, not area, my height, which is 30. Not too bad, right? Okay, next up is find the area of the shaded region below. This is definitely like composite figures. So first thing we're going to do is find the area of the square. All right, so what we're going to do is 11 times 11, or just 11 squared, which is going to give us 121. Next up, we're going to find the area of the circle. Well, remember, that's going to be right in the middle. So because it's in the middle, we know it would be the middle of this 11, which means that our radius would be 5.5. So we're going to do area of the circle. And remember, the area of a circle is pi times your radius squared. So we're going to do area equals 3.14 times 5.5 squared, which, well, area is going to be equal to 3.14 times 30.25. And when we multiply those together, we will get approximately 95.03. All right, that's the area of our circle. To find the area of the shaded, you're going to take the area of your your square, and subtract. So shaded is going to be 121 minus 95.03, and that will be 25.97 units squared. Okay, moving along. So, find the area of a rhombus, meaning that has diagonals that are 13 inches and 19 inches. So this whole side, or diagonal, is, I can't draw, 13, and this one, or vice versa, would be 19. So remember, the area for a rhombus is diagonal 1 times diagonal 2 divided by 2. We will do 13 times 19 divided by 2. 247 is 13 times 19 divided by 2 is 123.5 inches squared. Okay, so find the area of a rhombus with a perimeter equal to 36 centimeters and a diagonal equal to 12 centimeters. Okay, so a few fun facts about the rhombus, if you remember or not, is that all the sides are equal. So to find the side length, I'm going to do 36 divided by 4, and I'll get 9. So I know that each of these sides are 9. All right, I know that I have a diagonal equal to 12. I'll draw on my other diagonal. One thing about the diagonals of a rhombus is they bisect each other. So this is 6, and this is 6. Okay, well, I don't know if you see here, but we actually have a right triangle. We know 2 sides, so to find that third side and then find the area, we are going to use the Pythagorean theorem. So because we have a triangle that looks like this, 6, 9, and we want that. So we are going to do x squared plus 6 squared equals 9 squared. All right, x squared plus 36 equals 81. We'll subtract 36 from both sides, and we'll have x squared equals 45. I'm going to just write it I'm going to take the square root and I'm going to write it as a radical, which the square root of 45, that's 9 and 5. So that 9 can be square rooted, which means it would be 3 rad 5. If you're doing the decimal version, it's 6.71. It doesn't specify, it doesn't say leave it as a decimal or in radical form. So you can do either. I'm just more comfortable working with radicals. So what I'm going to do now is I know that this is 3 rad 5, and I know that this is 3 rad 5. So I'm going to take my whole diagonal 1, which I know is 12, and now diagonal 2, which I know is going to be 6 rad 5. I'm going to multiply them by each other. 12 times 6 rad 5, which is going to give me 72 rad 5 divided by 2. 72 divided by 2 is 36, and that rad 5 is protected in its radical, so it's going to stay like that. If you use the decimal, you'd get somewhere right around 80.4 centimeters squared. Okay, so that's that one. All right, here we go. Find the area of a regular hexagon, so 6 sides, with a side length equal to 30. Leave your answer with radicals. Okay, so I'm not going to draw a hexagon. What I am going to draw is, remember there's that central angle and the apothem cuts it in half. So what I'm going to draw is I'm going to draw the triangle that I'm going to be working with. So that's going to be 360 divided by 6 to give me my central angle. All right. And that's going to be 60. Well, that's so funny, guys. When I made my answer key, I solved it with a 5 as a pentagon, not a hexagon. Now I get to do this all on the fly. Okay, so that's going to be 60. We're going to divide it by 2, and we're going to get 30. So this is 30. This is 60. This up here is my central angle, but the apothem came down, so this is technically 32. Okay, I know that the side length is equal to 30. So that means the whole side is equal to 30, but the apothem cuts it in half. So I know that this part of the triangle is 15. Now I'm going to label it because I need my apothem. So across from 30 is n, across from 60 is n rad 3, and across from 90 is 2n. Okay, so I know that 15 is equal to n. All right, well, if n is equal to 15, then this side, this apothem, must be 15 rad 3. Okay, well, now I need to figure out my perimeter. Well, if it's a hexagon and I know one side is equal to 30, I'm going to do 6 times 30. I'm going to get 180. All right, well, my area is equal to my apothem, 15 rad 3, times my perimeter, 180, divided by 2. I don't have this calculated already because I solved it the wrong way. 15 times 180 equals 2700 rad 3, all divided by 2, which would give me 1350 rad 3 units squared. Okay. Now we're back on track. This one I solved correctly. Again, I'm just going to draw what would be my central angle. I'm not going to try to draw a heptagon. I'm not good at drawing heptagons. I know my limits. So 360 divided by 7, that's going to give me the central angle. That's 51.7 15.43. Let me double check that. That doesn't seem right. Okay, yeah, 51.43. So that's this whole angle. I need to divide this in half to get that angle right there, which is going to be 25.71. So right up here is 25.71. Next, I'm looking at this. Remember, the apothem comes down and it cuts the side, which we know is equal to 16, in half. So this is 8. This is where my googly eyes would come in. I want my apothem, which is right here. That's also my adjacent, and this is my opposite. Because the information I want and have involves an O and an A, that would be tangent. Tangent 25.71 equals my opposite, which is 8, over my adjacent, which is x. Hopefully you remember the trick that I showed you, where these swap places. So x is equal to 8 divided by tangent 25.71. And when you calculate that, you get about 16.62. So that's our apothem. Now, our perimeter is 16, right? Because one side length is 16. And it's a heptagon, so 7 sides times 7, and we'll get 112. So to find my area, I'm going to do 16.62 times 112, all divided by 2. Let me just make sure I did this correctly. 16.62 times 12 divided by 2. All right, you should get about 930.72 units squared. Okay, so if the perimeter of a rectangle is 24, all right, that means if we take this side A, this side would also be A, and this side would be B, right? Opposite sides are congruent. Find the length of the base and the height. Okay, so when A and B multiply together, they have to be 27. All right, well, there's only a couple numbers that multiply to 27 and will add to 24. So A times B is 27, 3 and 9. I think that's it. At least that's all my brain can think of right now. So let's say this is 9, this is 9, this is 3, this is 3. 9 plus 9 is 18. 3 plus 3 is 6. 6 plus 18 is 27. Oh, that works. So our base is equal to 9 and our height is equal to 3. All right, page over. Ooh, we're almost done. Yay. Okay. The entire rectangle shown below has a base equal to 22 meters, a height equal to 12 meters. If the 4 triangles were removed, so we would get rid of these 4 triangles, what will the area of the remaining figure be? So basically, we want to know, what is this wonderful figure right in here? First thing you want is the area of the rectangle. So we're going to do 22 times 12. We're going to get 264. Next thing we want is the area of one little triangle. Just one of the triangles. So that's going to be 4 times 4 divided by 2, which will be 8. Now, they're all the same, right? 4 by 4. So we're going to find the area of the 4 triangles, which means the 4 triangles are going to be 4, since there's 4 of them, times 8, which is going to be 32. Now we're going to take the area of the whole rectangle, 264, and we're going to subtract the area of these little triangles. And we will get 232 units squared. Okay, find the area of the smaller regular. Oh, this is supposed to say if. If the smaller regular hexagon is 72 units or inches squared. Ooh, this one needs rewording. Find the area of the larger pentagon. Okay, so area. First thing we want to do is find our scale factor. 4 over 14. These are both divisible by 2, so you can reduce that. You would end up with 2 over 7. We are talking area, so that means we need to square things. That means the area scale factor would be 49. So we're going to take 4 over 49, and we're going to set it equal to 72 over x. We are going to cross multiply. So 4x equals 3,528. All right, we'll divide by 4, and that'll give us the area of our hexagon, which is 882 inches squared. Okay, the area of 2 similar octagons is 98 meters squared. What is the ratio of their perimeters? So we're going to go from area to perimeter. We're going to do 32 on top and 98 on the bottom. All right, these are both able to be reduced by 2, which makes this 16 and this 49. All right, because we were area and that was squared, to get to perimeter or our OG scale factor, we're going to take the square root, which is going to give us 4 over 7. And that is our perimeter ratio. Okay, find the area of the kite. Remember, it's diagonal 1 times diagonal 2 divided by 2. Okay, well, unlike a rhombus, our diagonals are equal. So we need to figure out what this measure is right here and this measure is right here. I know this is 14, not the whole thing, just part of it. So I'm going to redraw. Wow, that is an interesting looking triangle. This triangle. All right, and it's 45, 45, 90. Okay, so n rad 2, n, and n. I'm going to solve for n. N rad 2 equals 4 rad 2. I'll divide by rad 2 and divide by rad 2. Oh, looky that. They just cancel out. So n is equal to 4. All right, so this side is 4, that side is 4, and this is 4. When I do diagonal 1, I'm just going to add 14 plus 4 and get 18. And when I do diagonal 2, I'm just going to add 4 plus 4 and get 8. Now, I'm going to multiply the 2. Area equals 8 times 18 divided by 2, which is 72. So 72 units squared. You'll notice the blank got moved to the back page. See it right there? Yay me. Okay, area of the triangle. Remember, that is our included angle, which this is. So we are going to multiply our sides, which is going to be 10 times 7 times the sine of the included angle, 25. All right, divided by 2, that is 29.58 over 2, and your area would be equal to 14.79 units squared. All right, here we go. Last 3. Ooh, Nelly, it gives us the radius. Oh, that means we have to find our apothem and our perimeter. Okay, but first things first, count the sides. 1, 2, 3, 4, 5, 6, 7, 8 sides. 360 divided by 8. Okay, that is 45. Divided by 2 is 22.5. So, let me move this up a little. And just redraw this friendly triangle. This is 10. This is 22.5. This I'll say is X, and this I'll say is Y. I'm going to solve for X first, and then I'll solve for Y. So I'm putting googly eyes on this angle. This is my opposite. This is my hypotenuse. That's across from my 90-degree angle. And this is my adjacent. The first one I'm going to use to solve for X involves an O and an H, which is so sine of 22.5 equals my opposite X over my hypotenuse 10. To solve, I multiply both sides by 10, and I'll end up with X equals sine 22.5 times 10, which gives me 3.83. Guys, remember though, that's only half. So this is 3.83. But to get the full side, I need to multiply it by 2. And that'll be 7.65. So the whole side is 7.65. Then I can find the perimeter. I'm going to do 7.65 times 8 because that's how many sides I have. So the number of sides, 8 times 7.65, the actual side length, and I will get 61.23. That's my perimeter. Now I'm going to find my apothem. So this time it involves my hypotenuse and my adjacent, which is ka, an A and an H. I will do cosine 22.5 equals my opposite y over my hypotenuse 10. Again, I multiply both sides by 10, and I end up with y equals cosine 22.5 times 10, which means my apothem, or y, is 9.24. And now I can find my area. So my area is equal to my apothem times my perimeter, all divided by 2. Well, when I do that, I get 282.88. All right, next up, find the area of a regular decagon, 10 sides, with a side length equal to 12. Well, I'm just going to worry about my perimeter first because that's going to be the most straightforward thing to do. Whoops. Which is going to be 10, the number of sides, time my side length, which is going to give me 120. Then I'm just going to draw a triangle rather than try to draw a decagon. And I'm going to remember that the apothem cuts the angle in half and the side. So the side that was once 12 all the way across is now just 6 right here. Next, I'm going to find that angle. So I'm going to do 360 divided by 10, which is going to be 36. But remember, that's this whole angle. And I'm going to divide it by 2, which will give me this angle, which will be 18. Okay, now I just need to figure out my apothem. So I'll just say that's x. I'll put my googly eyes here. This becomes my opposite. This is my adjacent. And I have tangent 18 equals my opposite. Oh, tangent because it's TOA, opposite and adjacent. Equals my opposite 6 over my adjacent x. Remember the trick, when x is on the bottom, they simply switch places. So this becomes x equals 6 over tangent 18, which is 18.47. Yay! We've got my apothem and we've got our perimeter. Now we can figure out our area. Apothem, 18.47, times my perimeter, 120, all divided by 2, which is 1,108.2 units squared. Okay, time for everybody's favorite. Blake, are you listening? I'm going to multiply these two together. I'm going to make my x over here. 3 times negative 6 is negative 18. This middle number, the middle, goes to the bottom, 7. I think of what multiplies to a negative 18, but adds to a negative 7. Oh, whoops, sorry, positive 7. That would be a positive 9 and a negative 2. Together, they multiply to negative 18. When you add them, they add to a positive 7. So I'm still using these first and last terms. 3x squared. I'm going to group it with 9 because I know I'm going to look for a GCF. And 3 and 9, they have something in common. Now I'm going to take minus 2x, this term, and group it with my last term. Okay, so now I factor by grouping. I look right here and see that I can factor out a 3x, which gives me x plus 3. All right, over here, I can factor out a negative 2, which gives me x plus 3. My parentheses have to match, and they do, so that's perfect. So now I have 3x minus 2. The two GCFs go in one parenthesis, and these two parentheses just become 1. Okay, so this is factored. Now I need to solve, which means I'm going to do, because remember it's still equal to 0, 3x minus 2 equals 0. So add 2 and add 2. I'll have 3x equals 2. Divide by 3, x equals 2 over 3. So x equals 2 over 3. And now I've solved for my other parentheses. X plus 3 equals 0, minus 3, x equals negative 3. And that's it. That is your study guide. All nearly 50 minutes of it. Good luck, guys. See you soon.